Good morning, my dear students. In this particular video presentation, again, we will discuss some more problems meant for class 12 of CBSE, which are very often tested in the board. The first problem meant for today is from integration. People may think it's a higher order thinking skills question, HOTS question, but it is not so. It is also an easier question as similar to any other question. See here, evaluate e power 2x tan 2x plus secant square 2x dx. This is the question given to you. Now, just put 2x is equal to t, 2 dx is equal to dt by 2. Therefore, 2 dx is dt, sorry. Now dx is dt by 2. 2 dx is dt, dx is dt by 2. Dx is dt by 2. Therefore, integral e power x into tan 2x plus secant square 2x dx can be written as e power t tan t plus secant square t into dt by 2, which is half e power t tan t plus c. Since integral e power x into f of x plus f dash of x dx in general will be e power x into f of x plus c. It's a very standard result. I repeat the whole process. I put x equal to t, okay, and 2 dx equal to dt, dx becomes dt by 2. This dx is replaced by dt by 2, 2x is replaced by t, here e power t tan t secant square t. Now, this is of the form integral e power t into f of t plus f dash of t dt, and here f of t is equal to tan t. This is given in terms of x, but here it is in terms of t anyway. Therefore, derivative tan t is secant square t. If I take this as f of t, by 2 is 1 by 2 is taken anyway out of the integral being constant. Now for half e power t tan t plus c will be the final answer, because this is the form e power t f of t plus f of t. Here f of t is equal to tan t. It's a very simple result, and you can have a generalization. If I have e power nx tan nx secant square nx dx, put nx equal to t, and my final answer will be 1 by n e power. In fact, you can replace the answer in terms of e power 2x tan 2x plus c. 1 by 2 e power 2x tan 2x plus c. Similarly, here e power nx, it is given e power nx tan nx secant square nx dx. It is 1 by n e power nx tan nx plus c. If it is e power 10x tan 10x secant square 10x dx, 1 by 10 e power 10x tan 10x plus c, and so on. You can have a you can think about the final answer this way. You can check your final answer in your CBSE examination, and you can give ABCD quickly in your competitive examinations. If it is tan 2x, it will be secant square 2x. If it is later sin 2x, it will be cos 2x here. If it is cos 2x, it will be minus sin 2x. If it is secant 2x, it will be secant 2x, tan 2x, etc. The derivative of this, not exactly the derivative, except the value 2 you should have. In fact, in the derivative I have 2 secant square 2x. Remember carefully. If you want to think about the derivative of this exactly, it should be 2 secant square 2x. It won't be there anyway. Therefore, I give you a generalization again. Integral e power nx tan nx plus secant square nx dx by using nx equal to t. Final answer will be 1 by n e power nx tan nx plus c. If it is e power nx sin nx plus cos nx dx, it will be 1 by n e power nx sin nx plus c. It is integral e power nx cos nx minus sin nx dx. It will be 1 by n e power nx cos nx plus c, etc. It is easier for you to use. Here I put 2x equal to t. There I will be using nx equal to t. It's a very simple result. Just remember the basic rule behind the whole lot. It will be easier for you to remember the final answer anyway. Next question goes like this. Find the area of find the area of the region bounded by the latus rectum of the parabola, y square equal to 4ax, y square equal to 4ax, a greater than 0. Why I am saying a greater than 0 is I need to know whether my diagram is facing towards the positive direction of x-axis or negative direction of x-axis. Find the area of the region bounded by the latus rectum, the parabola, y square equal to 4ax. Just see here, y square equal to 4ax is the parabola with vertex 0, 0 passing through 0, 0, a, 2a, a, minus 2a. When x equal to a, y square is 4a square, y is plus or minus 2a, and it is symmetric with respect to x-axis. Symmetric with respect to x-axis. Just remember carefully, x equal to a is the latus rectum. X equal to a is the latus rectum. This is my parabola. I should draw this rough diagram. This is my x-axis, x dash yx. This is my y-axis, yo, y dash. This is my line x equal to a. Okay, listen carefully. Now, due to symmetricity of the curve with respect to x-axis, required area is equal to twice of shaded area in the first quadrant, which can be given by twice of 0 ta y dx, where my y is 2 root a root x, which is 4 root a x power 3 by 2 by 3 by 2 0 ta. Just see here, 2 into 2 root a becomes 4 root a. Root x integral becomes x power 3 by 2. Apply upper limit. This is 8 by 3 into a power half into a power 3 by 2. A power 3 by 2 minus 0 I will have, which is 8 by 3 into, this is reduced to a square units. This is the required area. I just repeat the whole process. Y becomes y square equal to 4x is a parabola with vertex 0, 0 passing through 0, 0. When x is a, y is 4a square, 2a plus or minus 2a. Y square is 4a square, y is plus or minus 2a, and it is symmetric with respect to x-axis. Y is replaced by minus y. Equation remains the same. It won't change. Equation remains the same. For this is the diagram meant for that. Now x equal to a is the parabola. For example, if it is 16 x, let us say 4a is 16, then x equal to 4 is the corresponding latus rectum. This is the equation to latus rectum. Now, due to symmetricity of the curve with respect to x-axis, required area, this area is the same as this area. For required area is twice the shaded area in the first quadrant. If I mean to say twice of 0 ta y dx, y is 2 root a into root x. That's 4 root a into, I mean to say, x power half integral becomes x power 3 by 2 by 3 by 2. Over 8 by 3 into, I mean to say, a power 3 by 2 to a power 3 by 2. A power half into a power 3 by 2. So reduced to a square. Over 8 by 3 a square units will be the final answer. 8 by 3 a square units will be the final answer. For example, if it is, let us say, y square equal to 16x. I mean to say 4a is 16. My a is 4. I am talking about a particular case again. It can also be given anyway. For my answer will be 8 by 3 into 16. You will get automatically. You can proceed here 0 to 4 the same manner I will be doing. For it will be here the integral part will vary. 4 into this is root 16 is again 4. Integral 0 to 4 x power half dx. Now 4 is 8 into anyway x power 3 by 2 by 3 by 2. 0 to 4 I will have. which is 16 by 3 into, I'll end up with 4 is in, I'm sorry, 1 second. Yeah, this will be 4 power 3 by 2, which is anyway 8. 16 by 3 into 8, which is 128 by 3 square units. I am talking about a particular case also. I will explain once again for you anyway. Here you can just check whether your answer is right or wrong. 8 by 3 times a square is the final answer. 8 by 3 times 16, 128 by 3 is correct. If instead of y square equal to 4x, if I have y square equal to 16x, what happens? I am trying to explain. Here 4a is 16, a is equal to 4, x equal to 4 is the lattice rectum. Now for the variation lies, the rest of the things will be as it is, you can write seriously. Now here 4, 2 into, here it will be 4. Sorry, I should have 2 here. 2 into 4, 0 to 4, x power half dx. Root 16 is 4. 8 into x power 3 by 2 by 3 by 2, 0 to 4. Therefore, it will be 16 by 3, 4 power 3 by 2. 4 power half is 2. 2 cube is 8. 16 into 8 is 128 by 3. 8 by 3 into 16 is nothing but 128 by 3. Now, for a particular case, you can verify what it is exactly. Whether I am able to get 8 by 3 a square or not. For a particular case, for a particular value of a, what the final answer is, you can check. In your competitive examinations, you can put a tick mark. 8 by 3 into a square is how much. You can easily write the answer quickly without even calculating. This is the area bounded by the lattice rectum of the parabola in general. Then I'll give you another simple problem. It may be tested in your examination for MCQs. In fact, I'll give you a simple rule. Write the expansion of a 3 by 3 determinant in 6 different ways, let us say. Let me say this is A11, A12, A13, A21, A22, A23, A31, A32, A33. This is my matrix A, let us say. Okay. How to expand this in 6 different ways? Actually, I'll give you a simple explanation. In fact, every square matrix can be treated as a determinant. Every determinant has an expansion. The expansion is given by sum of products of elements of any row or any column with the corresponding cofactors. I repeat again, any square matrix can be treated as a determinant. Every determinant has an expansion, and the expansion is given as sum of products of elements of any row or any column with the corresponding cofactors. Therefore, there are 3 rows and 3 columns. Therefore, if I take the elements of first row, I mean to say this is A11 into its cofactor plus A12 into cofactor plus A13 into cofactor, or A21 into its cofactor plus A22 into its cofactor, A23 into its cofactor, or A31 into its cofactor plus A32 into its cofactor plus A33 into its cofactor. Similarly, for column I can write A11 into cofactor plus A21 into its cofactor, A31 into its cofactor, plus A12 into its cofactor plus A22 into its cofactor. That is how it is being expanded. Therefore, if in general capital Aij is the cofactor of small aij, then determinant A, there are 4 different ways. A11 into capital A11, A12 into A12, plus A13 into A13. There are 6 different ways. What are they? A21 into A21, plus A22 into A2, capital A22, plus A23 into capital A23, or I'll have A31 into capital A31, plus A32 into capital A32, plus A33 into capital A33. Similarly, I'll have A11 into A11, plus A21 into A21, plus A31 into A31. Similarly, here I'll have A12 into A12, plus A22 into capital A22, plus A32 into capital A32, or I'll have A13 into capital A13, plus A23 into capital A23, plus small a33 into capital A33. In these 2 cases, they are small letters These are small letters, okay, in these two cases. By mistake, I wrote capital initially. Therefore, small a to small a. Therefore, this is with respect to row 1. This is with respect to row 2. This is with respect to row 3. This is with respect to column 1. This is with respect to column 2. This is with respect to column 3. It's an easier way to remember. If it is tested, you should be able to answer in MCQs. And this is the way the expansion of determinant is being done in general. Okay. Then, if another important fact, just remember it's not related to this answer of this question anyway. If I am going to multiply elements of any row or any column with a cofactor of the corresponding elements of another row, okay, then sum of products of elements of any row with a cofactor of elements of another row, corresponding elements of another row, it will be 0 always. You can easily check A11 into capital A21 plus A12 into capital A22 plus A13 into capital A23. If you do so, this will become always 0. You can check anyway. This is also an important result. Remember carefully to apply in your board examinations. I repeat, A11 to cofactor of capital A21. Some other row, A12 to capital A22. A13 capital A23 will be 0. If I take the cofactor of the same element and multiply and then add, it will be the value of the corresponding determinant. If you do this way, it will become always 0. Remember this rule anyway carefully. Okay. As usual, I'll check for the calculations. If there is any correction, I'll do. Otherwise, I'll upload as it is. Thank you, students, for patient watching.